So there's this article that one of my former students sent to me and asked if I agree with the general sentiment that too many people who are trying to self-teach themselves data science end up doing it the wrong way. So here the article, Chris Conlon, here the author of the article posits that there is a right way and there is a wrong way to learn Python. It's not a new article. This is from June 23rd, 2017. But let's take a look at the points that Chris is making. It says here that many people of many different ages get burnt out on learning Python because they went about it all wrong. The key to learning Python is to do just that, no more, no less. And if you look at the sample files, one of the snippet in here, you said this is such a common workflow, right? If you're learning Python, if you're learning data science, you see import numpy as np, import pandas as pd, imports and a ton of like CSV, JSON, matplotlib is down here. So, and then there's a few date utils. If you're doing some sort of computation, you have import PIL, pillow, you have import OpenCV. It says that a lot of times when you have people trying to self-teach themselves, data science or Python, they get hung up on package-specific syntax while trying to learn vanilla Python. And he proceeds to say that people can get burned out on Python when they try to learn it in conjunction with packages that alter its syntax and behavior, because you end up actually, instead of trying to learn what Python does, you're actually learning about what the package does, and it abstracts so much, so heavily from what Python, the vanilla Python itself, that you may end up confused yourself, thinking, am I actually learning Python, or am I just learning this specific syntax of behavior? And this is not just a Python thing. I mean, if you learn R, there is also the same sort of the same, not consensus, but the same. There is an opinion that if you learn like tidyverse, for example, they are very opinionated, very productive frameworks for doing data science. That sometimes they augment R so much that you probably end up learning tidyverse and you cannot do anything in R without the use of tidyverse. So the author then proceeds to recommend that beginners should avoid complex packages to better familiarize themselves with vanilla Python, and give you some examples in here. Now, what do I think? So what I think is that it's generally hard to give wide, broad advice that tries to reach everyone or as many people as possible, because what I feel is learning paths are somewhat more prescriptive, meaning it works differently for everyone. So what works best for one person may not be the best for another person. So if you only have 6 months to secure a new role where your job involves using numpy or pandas or OpenCV, any of these tools, then I feel like if you only have 6 months to secure the job and then hit the ground running, there is absolutely nothing wrong to just pick up the tools that you need, whether it's OpenCV, pandas, numpy, scipy, dplyr, tidyverse, ggplot, matplotlib, anything, right? So that's about what you need to get started in the new data in the data science domain, at least on an entry level. These are the main packages, these are the main libraries, the main frameworks, and you want to get yourself very familiar with them. And so if you only have 6 months, just focusing on those frameworks, they make you ultra productive, and I feel it's a pretty good learning path. But if you want to make programming something that you do very, very well, then yes, I agree to some extent with the general sentiment of the author. In fact, I agree with it so much that I'm actually going to make a tutorial series all on its own. So what we're going to do is we're going to write analytics and data science tools that we use in a command line interface, but all with just Python. So we don't have, I haven't really thought of a title for the video for the series, but it's probably going to be something like data science in Python without any library. So we don't have any of this. I'm just going to remove all of this. And this is, so common. You see like import beautiful soap BS4 for all the web scraping, request URL lib, matplotlib, time utils, all of this stuff, right? So we're just going to remove all of this. And instead, we're just going to focus on the raw vanilla Python experience, okay? So I'm going to just, we're going to write analytics and data science tools, because ultimately a lot of my audience are still, you're here because of the data science content. So we're going to just build a few analytics tools and stuff, but I'm going to focus on the data science application of things with just Python. So no cheating, no libraries, definitely no pandas, no numpy, but we will use only Python, just kind of like from a ground up level. And as an added bonus, we will then add an alias to our shell and have this script be given executable right, so we can call a command line application from anywhere we want. The resulting output, let me show you how it looks like. The resulting output is something of a command line interface, and so if we do something like tscoreboard, it's going to go ahead and print out our output. This is an accumulative score. This is a productive score. So it's going to do that. And if we have an optional library loaded in, so I'm going to say live OS, that's my optional library, then it's going to load in a pretty printing table just to print a better looking table. So if I do tscore, it's going to give me a much better formatted, a much prettier looking table. But even without that, so if I have no packages at all, so let me deactivate the virtual environment, and I have no packages installed at all, it's still not going to fill, it's still going to run, and it doesn't require any external package. So 0 external package, just completely Python on it itself. This may seem easy or trivial, but it's actually not, because the resulting output, this utility tool that computes your productivity score, it needs to do it in a way that uses group by. If you have done any kind of work in NumPy or Pandas, it uses group by, it uses some sort of aggregation, so it group by aggregates, and then it forward fill with date time. So if there are any missing dates, if there's no recorded dates, no recorded value for this date or that date, it has to fill them with the forward fill. So all of these stuff are provided to you by something like Pandas, but we're not gonna even do that. We're not even gonna cheat. Okay, so we're gonna just use core Python module to achieve that. I would say also one important point about the point of this exercise is that if you go back to the main article there, when you try to just use Python itself and you package this into your own package, or you try to do this for your own tools and stuff, you also speed up your computation, because what you're gonna do is likely gonna be so much more lightweight than what you get from loading in a library like Pandas and stuff. You see there is a few comments here that says using Pandas just for output formatting seems like overkill. There is a question about how do you pre-enlist as tabular data. This is kind of like while I was doing this script, I was looking at some of these answers in here, and you can see a comment here that says that come for the output formatting, run away screaming because of 10 minutes numpy compilation that make my computer sound like a hair dryer. And so there is this and if you actually look at some of the articles here, or you try and go to the repository and look at the size of the package itself, you may not realize, but NumPy, Pandas, most of this stuff are pretty heavy actually. So if you have only, for example, some SciPy and Pandas, in total you would have a size of the package that goes across 250 megabytes. So that's quite something, right? In fact, if you were to have something like NumPy, SciPy, Pandas, and Matplotlib, this alone, if you run this in a Docker, so open up a Docker container, spin it up, just install the 4 of them, you will see that this could go up to 508 MB. That's actually that's quite something for a utility tool that you want to create. For something that it should be lightweight. You should just write the command, get some tables printed out and stuff. You probably don't always want to load in NumPy, Pandas, SciPy, a ton of all of this, and have this 508 MB sitting around. So I would say there's a lot of good reasons for you to want to learn what you can do in Pandas, because what you can do in Python, because that gives you option. If the job calls for it, you can load in Pandas, you can load in NumPy. But if you don't absolutely have to, you can choose not to. Right? So kind of add another toolkit, add another kind of a tool to your toolbox, and make it an optionality for you. So if you want to, you can, but just having the option of saying that, nah, I'm just gonna stick to vanilla Python. That's actually a pretty nice thing to have anyway in your toolkit, right? So let's get started. So we're gonna close out my browser, and we're gonna just go into our demo file. And we're gonna start from a clean demo file. Okay, so I haven't really thought of a title for this, but let's start from a clean demo file, and I'm just gonna write and I'll comment here and there as we try to flesh out the script itself. So if you have Python or if you have Visual Studio Code installed, you want to make sure that your virtual environment is set. I'm gonna first select my interpreter. I'm gonna go to Live OS. So in the Live OS itself, this is quite empty. If I show you what I have in here, it's really not much. Probably the only thing we need, because of the data that we're trying to work with, it's kind of the TaskWarrior library itself, and so that's the only thing we need. So we're gonna say from tasklib import TaskWarrior. Now, if you don't know what TaskWarrior is, I have another video that I'll point you to. You should go and take a look at it. It's a really cool productivity tool. Allows you to do all your to-do manage your productivity suite directly from a terminal line itself. So if you wanna really thrive in that kind of in a terminal, in a command line environment, not just survive in a command line environment, then I recommend you take a look at TaskWarrior and try and set it up on your own. There is a separate video, so I'm not gonna go too much, talk about the details too much, but I'm just gonna show you how we can go ahead and replicate a lot of the things that you imagine would work. Or we try to replicate a lot of the Pandas functionalities, for example, like the group by that I talk about, the forward field, the back field, the date time, the aggregate, all of these functions without using Pandas. So we're just going to be vanilla Python. So if you're interested in how that's possible, or what are the things that hopefully you pick up a few skills here and there as well. But if you're interested in that, just continue watching. So I'm going to close out the sidebar and just zoom in a little bit so you can see better. So this is kind of my, maybe when we, when it gets longer, we'll do that. So let me bring up my terminal a little bit so that you can see the full view of this, like this. So you can see both my editor and my terminal at the bottom. All right, you can use any editor you want. I'll put the link, the code, everything on GitHub, and you can use that as a reference if you want to. And so let's get started. So first of all, we're gonna just bring in our TaskWarrior task itself. If you already have yours, then that's great. If you set up TaskWarrior, if you haven't and you wanted to actually follow along and you want to set up your own TaskWarrior, you want to set up your own to-do productivity system just like I did, then just pause the video, go back to my earlier video about TaskWarrior and set it up. Again, link to this link will be in the description, but I'm just gonna assume that you have done that, or that you just wanna learn something from here without actually doing it. So first thing, I want to point to where my TaskWarrior files are. So I'm gonna just say TaskWarrior, and I'm gonna say TaskWarrior, and I'm gonna say my data location would be, this is where I put them. You may have them completely differently, and I believe the default, if you don't have if you didn't change the original location, you didn't even need this. Right? If you didn't even change that. But for me, I actually did. I changed the data location and I moved them to a place where I version control just like the rest of my productivity systems. So I'm gonna just have it there. And then once you have that, I'm gonna just put all my completed tasks. So I'm just gonna say print task completed. And once I save this, I can go into my terminal and I can just say Python. Actually, let me make sure that I'm in the right OS. Virtual environment, and I'm gonna just say Python demo.py, because that's the name of my file. If you name it differently, you want to call it differently. So I can see all of my to-dos in here that I have completed. So I see all the completed to-dos in here. If you don't want to see the completed, you want to see the pending, then let's do that as well. Let's say print, and we're just gonna say pending. And now we can see in the terminal, we see all of the completed tasks and we see all the pending tasks. All right. So what we're gonna do is, we probably don't need any of this. What we want instead is we're gonna, in fact, let's maybe put everything into a main function. So it's more nice and tidy. It's more modular that way, and we can port them later. We can say, okay, from another file, I want to import this, import that, right? And what we're going to do is we're going to say completed, just as what we did, PW, I'm going to say task, I'm going to say completed. Okay, and now what I want to do is that if I look at all my tasks here, all of the tasks, they have sort of attributes that I can crawl for. So here I can imagine a loop, maybe create a completed list where I take all the attributes that I really need or that I really want. In this case here, let's say we want to take for each of these tasks, we want the project attribute, we want the end task attribute, we want the effort attribute, we can do that. And if we just print the completed, and it says that if we run this directly, so let's go ahead, clear the screen a little bit, let's say Python demo.py, that's gonna go ahead and do that, right? What we're going to do is to actually just have it outside of the function so that we can just look at those things, run through it iteratively, remove all of this. And later on, once we've done developing, we can put them into our main function again. So we're just going to have it all outside the function so that it's easier for us to just iteratively play around with it. And now we can do completed. There we go. Then from here, we can take a look at all the attributes there are. So let's say completed. And let's take the first task, 0. Okay, let's take a look at this. Okay, this is a task in my to-do app. So in the TaskWarrior app itself, well, I see that there is a to-do called completed upload passport to go pay for the KYC. So I need to do a KYC. I need my passport for that, and I didn't have my passport at the time, so I added that as a task. And I'm like, when I collect my passport back, I send it to the embassy. But when I when I collected my passport, I want to go ahead and perform this task. Then I've done that. So this is in the completed list. And so what are the attributes that are on here, right? So I can take a look at the attributes in here. I can say does it belong to any project? It doesn't belong to any project. What about the end date? Oh, it does have an end date. So this is the end date. This is I'm in Jakarta at the moment, so you can see the time zone info. I could choose to not have the time zone info. I could remove that. I could also just choose to maybe have the date part of it. So I can do something like date. And now I'm only just going to get the date itself, which is exactly what I need. Because in the final visualization, I don't actually need the hours, I don't need the minute, I don't need the second, I don't need the time zone information. Because all of my tasks is actually done in the same time zone. I'm actually doing all of this work in Jakarta anyway. So I don't have a reason to actually want to look at time zone or use the information to perform any kind of analysis. So that's kind of cool. We know that. What about other attributes? For example, like what about the tags in there? Do we have any tags associated? In this case, there is a tag, and it's in the set. You see live OS in here. So I can see the tags. If there are multiple tags, then you see multiple sort of values. But right now, there's only one tag. It's associated with live OS. If I look at the second tags, the second task, the tags of the second task, well, there is nothing in there. What about the third one? And I can iteratively go through that. In fact, I could just write for task incompleted, and I can just say print task, and I can see just print the task tags. It's kind of like that. And I can see, oh, some have the tags notes, some have the tags terminal, live OS, some have terminal, some have learn. So all of these are different tags. And I can do the same thing for something like end date and like this. But again, remember, I don't want to see the whole time zone thing. It's too much information. So I just want to say, just give me the date. That's all I need, right? So just print that. I can see, okay, some of the tasks are completed in here. So when you try to just iteratively just try to run through within the console itself, you get to really quickly inspect the data that you're working with. And let's also try to make sure that, let me go back to task 0. I really don't need to see all of this anyway, so just gonna go back to task 0. I want to see maybe what is really important for me is the score, right? And that's because it's not task, it's actually completed. So let's do completed and stuff. 0, and let's say score. Now it should work. It says, okay, the first one have no score. Okay, the second one have a score of 1. So we see that there is an issue now. Is that what if that has no score? So we need some sort of get, right? So we can do something like get, and we can say get completed 0. If there is nothing, you can give a default value of 0. So this is kind of if this is a dictionary, you can do that. You can say try to get. Actually, instead, what we're gonna do is sorry for that. We said get complete and 0. Get or 0. What it says, it also have no attribute get because that is not a dictionary. So there is another option we can do is to just do an OR. So we can do something like completed 0, score. If there's no score, we put an OR 0. So it's gonna try and get this value. If the value here is a valid value, then it's gonna be that value. But if there is no valid value, it's gonna just return 0. So let's do that. That's kind of what we want. We change that to 1. Well, you see, it has no effect because the value is 1. So the OR is ignored, and it's gonna just take the first value. That's perfect. That's what we want. Maybe we can also take the effort if we want to. Just maybe have another kind of visualization that visualize our effort. So in my productivity system, the custom attributes that I have that I use a lot in my productivity system, whichever tools that I use, is I try to script my productivity task to feature something called a score. So I'll give myself a score when I perform something that is that takes considerably more effort. So something that takes more effort should have a higher score, and something that I dread doing, that I don't like doing, it should have a slightly higher score. So the more effort I put into something, I should get a higher score. So something that have low score for me is something like having to attend meetings and stuff. So I really don't like meetings. So every time I have to attend meetings, I have a score of 0. When I do something like coding or programming or write an article or anything like that, I usually accumulate a bit of scores there. And effort has to do with sizes. So effort is something like, for me at least, what I do is I have the is usually in the set of access. These are very, very small tasks. These are tasks that I can do in 5 minutes, and then small tasks are things I can do within 20 minutes. And then there's the medium tasks, large tasks, XL, and so forth. Okay, I think it's up to XXL and it's very XXL is very rarely used. Maybe in a whole calendar year, I have maybe 2 or 3 XXL tasks. For the most part, I try to break the task down to really small parts that I can read. So maybe 80% of my tasks are within the S to L range. So it's either small tasks, medium tasks, or large tasks. Extra small tasks are good when I have just 5 minutes to squeeze before the next meeting. I can quickly open up my tasks, and I can see, okay, what is something that I can work on within a 5-minute span. So I can knock them out, within 5 minutes. So those are how I separate my tasks. So let me take a look at the effort. It says this is M. So again, I can do something like for task and completed, and I can just print. I can say task, and I can just put effort, just to take a quick look at it, and you can see that there are some like M, there are some like S, and if you see that there is not, if you see that there are none, then again I need to handle that case. What do I do with the case? What do I do with the task that return no effort, right? What do I do with it? So let's go in here, and one thing I thought about doing, just looking at what we see here, is that we probably want a list, and we just append to that list. All right, so I'm gonna just go ahead and just create a list here. I'm just gonna call completed list. This is the completed list here. We probably don't need the print statement anymore, and I can have it here. And then I'm gonna just do for task in completed, just kind of what you see in the terminal. And I'm gonna do this for loop. So I'm gonna say cl append to my list, and within that I want to append sort of some of the attributes that I need, and I want to put them in the tuple. So what I do is I'll just create something like this, and I will say, ideally I want to try something like task.get project, but I can't do that because this is not a dictionary. At least it's not coded as such. Let me try that. If I say task completed 0, we've seen that this will not work. Don't think. Yep, because task object is not a dictionary. Let me see if I do it, make it a dictionary, would it work? Completed 0. And then from here, if I try to get, let me just even try dig first. Alright, so it wouldn't even work because it would just create nothing. So if I do a get, it wouldn't even make sense there. So let me just go back up to my terminal, and instead of doing the get, let me just do the save thing. I know it will always work because from what I see in the terminal itself. So I'm going to just go get the project in there. I probably don't need a description because it's kind of like an aggregate summary anyway. So I'm just going to say task. What do I need next? What I'm interested in, what is the most important is this one. This is the end date, right? So I want to have the end date. And so we're just going to say end, and just do exactly what we see in the terminal. This is kind of what we did earlier anyway. Just put them up there, and we're going to just go ahead and finish up the rest. Okay, so what I did here was I have my effort. I said that if you can't find effort, so I see that some of them are none. If you see a none, then I just want you to replace them with an empty string. So if you see a none, replace them with an empty string so that it doesn't cause an error later when I'm trying to aggregate. I'm trying to summarize all my score based on effort or trying to do any of that sort. It wouldn't throw an error. And score is the same idea. If I have a score, use the score. If I don't have a score, 0. Okay, so don't throw an error because you don't have one. So that would be easy when I later, the main idea I'm thinking here is that later on I'll try to do something like iteratively sum. So later I'll do something like iteratively sum the score. So it will be like a total score, and then it will be a score for score in CL and stuff. I will do something of that sort. Where in CL scores. So CL scores I haven't really created, but I will then create CL scores and just take all of them, and I'll just sum that up. Or I would do something like this. Iteratively just sum that across. Sum up all the scores. So here you have a for loop. And within the for loop, you will have something like, this is of course pseudocode, but within the for loop, my thinking is that I would just try to sum across all the scores. So I want a 0 so that it doesn't throw an error, because then I'll be adding something like a none. So I don't want that to have to be an issue there. So that's kind of the main reason why we're doing that, right? But before we do that, I just want to make sure that if we do all of this correctly, Now CL would be a list. If I take a look at how that would look like, quit from a terminal. If I save the demo and I go back in here, we just iteratively just run it again. And if I show you the CL now it would have all of this, right? So it would have the project. If the project is none, you see a none, and then you have datetime.date and live OS. If I just show you a quick glance of things, there is already an issue that I see is that the date itself is not actually in the order that I want, because when I print out my stuff, let me just maybe create another shell just to show you what it looks like, right? And here I'm just gonna say tscore. If I print out my stuff, I actually want them to be in this ascending order. I want it from 9, 10, 11, 12. I want it to be in this nice kind of something that makes sense to me, at least. Maybe it doesn't make sense to you, but for me, I want to see like 9, 10, 11, and I want to see the score accumulate on this end, right? And so what would make sense in this case is to actually have 9 first and then 19 last. That's the kind of ascending order that I'm looking for. But if you go back to my Python shell, you see the completely inverse opposite of that. So I think there are a few ways you can sort of deal with that. So one thing you can do is to make sure that all of this is even sorted first, because if you look at 19 and then you see 18 and then 16, it looks like it's descending, but we're not really sure if that really is. So let's just go ahead and just sort this list, and we can do that by using a sorted function, and we can say sorted. What is the name of the list? It's called CL. So we just say CL, and you can pass in a key. This key you can either pass in a function or just use an anonymous function called lambda, and you can say lambda, and you take. Now there are so many attributes in there. If you take 0, it's gonna be sorted by project. So if you want to sort by project, you put 0 here. But I want a second attribute. So the second attribute is the datetime.date. I want to sort by date. So this is what I'm gonna do. I'm gonna say 1. All right, and now it's gonna be sorted by that. And if I go back to my CL again, yeah, it's sorted, but then I have to give a different, maybe CL underscore sorted or something. But you see now that it goes from 9 and then 10 and so on and so forth all the way till 19. All right, so this is, now that I know that the logic works, I'm just gonna add a quick command. I'm gonna say sort CL by the end date. Okay, and I'm gonna call it what do you want to call it? CL sorted maybe. All right, so just say sorted, and we're gonna CL, and we're gonna give it a key. So here, this is because I know that this is the second element, so I'm gonna put 1. If you want to sort by effort, just put 2. If you want to sort by score, just put 0, 1, 2, 3, 3. All right, so it depends on what you want to sort it by. You can pass in a key in this second argument here, but I'm not gonna do any of that. I'm just gonna sort by date because that makes the most sense in this case. All right, and now what we're about to do next is we're gonna try and say, can we find a way to just meaningfully try to summarize the score? So try to have a group by summarize, group by sum score based on CL sorted. So now this is where things get a little bit more fun, because you would then say, well, can we now bring in pandas? Well, the thing is, we're not going to use pandas. But if you use pandas, you'd probably be tempted to think about something like using something like CL sorted, and you say something like group by, and then you group by what? You group by maybe the end date. So you group by the first, let's say date column, and then you do a sum, right, of the score. But we're not going to do that. So how do we write our own function and maybe save ourselves 500 MB of library or space? How do we do that? So to do this, we need to introduce a something from core Python. So I'm not really cheating in here because I'm actually doing something that I'm actually importing something that is provided by Python anyway. So I don't have to install any dependencies. Anyone with just basic Python installed would have access to that anyway. So this is not really against the rules. So I can just go ahead and use into tools import group by. Now group by, again, I said it's provided to you by Python anyway. It's part of the core Python library. So you don't actually need anyone to go and install this external third-party package. So it's not really cheating, all right? It's still within the rules. So I'm going to use group by to do that. And so this is where you actually pick up something new probably, right? Because you up to this point, if you're very used to using pandas and stuff, a lot of this stuff you would never imagine you could do without pandas. But here it is, we see that you can actually do something without pandas. So how do we do this? So you can go ahead and try and maybe go into a terminal again and try to just use a group by and see how do you group by something. So let me show you that before we write the script. Okay, we can say group by, and within group by, we just pass the name. We say it's based on CL sorted, so let's just say CL sorted. And again, you give a key. So we're gonna do very similar to what we did above. Now, what do you want to sort it? What do you want to group by? You can group by project, you can group by end, you can group by effort, you can group by score. What do we want to group by? We want to group by the end date, right? So what do you have here? Have the second element. So second element would be 1, first element would be 0. So you can do something like this, and it would just group by the end date. So if we run that, group by is not defined because we haven't done that in the terminal. So let's go ahead and just say from tools import group by, paste it in here, and complete that. CL sorted is not created, so let's do that as well. Paste it in here. Now we can do group by. Okay, now it has a group by object, and now within the group by object, I guess you can try to print that out. And if you try to sort that out, I'm not sure if it makes sense, but you have like, okay, this is the first item, and then there is a grouper object, and you can perform something in the grouper object. So this is kind of the key, and then this is kind of the value key, and then kind of the value. So in a way, you can now use something a fancy list comprehension to manipulate the key and the value. So you can have something like a list comprehension, and you can say key, and then this is a grouper object. So we're gonna say kg in group by, and we're gonna do exactly what we wrote in the command line, and we're gonna just give the key, and that would be exactly what we wrote in the command line as well. So again, we want to take the first item, so we're gonna be 0, we're gonna be 1. So 1 would just give us the second item. If we put a 0, that would give us the first item. So that is kind of a simple list comprehension. But what do we don't actually want a KNG, because that's kind of meaningless as well. What we want actually is for us to take all the key, and then we want to sum all of the score in each of the in the values in here. So how do we do that? Now we can have another list in here. So we're gonna have a list in here for kg, and within this list itself, the key is just gonna be key. We don't want to manipulate this. You can actually change this if you want to, but I see no reason to. So the key is still gonna be this. So 3 is gonna be a key, 3.9 is gonna be a key, 3.10 is gonna be a second key, 3.11 is gonna be a third key, and so on and so forth. So I'm just gonna leave it as is, because that's kind of what I want as a key. But the value itself, what we want is that in the group object, we actually want to take the 0, 1, 2, 3. We want to take the score, which is gonna be the third. In terms of index, it's going to be number 3, because there's 0, 1, 2, 3. Okay, that's a fourth item, so index 3. So what we want to do is to just sum, and we want to sum for the third value, the index number 3 for V in G, and then 4KG in group by. I know this is kind of a handful. If you sort of need to stop a little bit and pause and think, you can. But what essentially is saying is that for each of these group items in there, look into the fourth item, which is the index 3, and you sum all of them for V in G for KG in group by. So yeah, it's kind of a handful in there, but that will give you exactly what you want, right? So you save it, and we can now go ahead and just quit this and just print that out just to make sure everything still works. Python demo, and if we do agg_date, okay, that's good. It gives you, let's just take a look and see things are still correct. So it says on a 9, there's 0. This is the sum of it. If you don't want to sum, you want to take the max, you can do that. If you want to change the mean, medium, all of this, you can do that. But for me, what makes sense for me is sum. So we're just going to keep to the sum. And maybe what would be nice is to have it as a dictionary. Like, have it as a dictionary would be nice, because then I can refer to the key value pair itself, right? So I'm just gonna, this is very easy to do. Just gonna go ahead and just call it date dic. So date dic would just be a dic, and that would just be a aggdate. So aggdate dic equals to dic aggdate, right? And now I want to also, at this point, I want to stop a little bit and think about another kind of scenario that may happen. Is that what if there are days where I was on holiday, where I have actually no tasks, and so it skipped a few days in here, let's say 9, 10, 11, 12. So it's lucky that I did not actually have any breaks in all the days here. But I want to account for the case that what if one of the users who's using my tool actually took a break, and then there is 2 or 3 missing dates in there. So in Pandas, what you do is something like a forward field, like a forward field, or a backward field. Meaning, if let's say from 18 and then 19 and then 20, let's say 19 have no values, or let's say there is just completely this missing entry, there is no 19 at all. What do we do? Now, in data cleaning and data cleansing, what you would think about doing is you said, well, if there is no 19, you would take maybe the mean of 18 and 20 and find the mean of that and fill that value. Like in the time series model, you probably do that, or you probably try to forward fill. You say that if there is a missing entry, you take the last observed value and you forward fill it. A backfill is doing the opposite. If you say that there is a missing value, you look at the day ahead of it, and then you take the value and you backfill it. All right. So there's all of these different ways you would probably there are different approaches to solve this kind of missing value approach, especially in a time series context. So what I'm thinking about doing in this case is I'm gonna actually have to first define a start date and then an end date, so that I can actually fill up, make sure that it's sequentially filled between the start date and the end date, and there's not gonna be any missing value. So I think that's kind of the next thing we should be doing. So let's go ahead and say start date, and we're just gonna take the aggregate date that we have up here, which is right here, and we're gonna take the first value, and we're gonna take the first index of this. So we're gonna take this, and then we're gonna take 0, because that's gonna give us only this, right? So let's go ahead, say aggregate date, take the first value. This will give us the whole thing, but we only care about the date, we don't care about the value. So we're just gonna put a 0 in here, and we're gonna do the same thing here, but this one we just take the last, and this is just gonna be the end date. All right, so -1 means take the last item in the list itself. So the last item would be this one, and you don't really want a value, you only want the date object itself. Okay, and now we can try to fill the whole date. We can complete series, a complete sequence of dates here, and you can call it filled date. So FILLED. You can call it complete dates, you can call it full date, whatever. But that new variable that you create essentially acts as a sort of a sequential sequential series of date from the first till the end. So if there's any missing value, it's gonna fill it in there, right? So I just wanna, maybe for me, I'm just gonna keep it simple. I'm just gonna call it full date, and it's just gonna be a simple dictionary. So let's just go ahead and say full date equals to just empty, and I'm gonna say, while the start date is lesser than the end date, then continue to build up the start date and add 1 day at a time. And by the time it reaches an end date, then you stop. Okay, so this will make sense when you see me type that out. So I'm going to say while start date is less or equal to end date, and let's make sure end date. What does it look like? Okay, end date is not even created and stuff. So let's go ahead and just copy 2 of this. Go in terminal. Okay, now let's take a look at start date. Okay, that's cool. What about end date? Okay, that's cool, right? So we have the start date, we have the end date, and now we're gonna do this for loop. We're gonna say from 9th of March all the way to 19th of March, it should add 1 day at a time up to 19 itself. So this is where we can do our while start date lesser than end date. And what do we want? We want to fill the full date. So the way you append to a dictionary, the way you append or add to a dictionary, or you do something called an update. An update is like if the value is there already, then just give it a new value. If not, then just add it, right? So we're gonna go ahead. I think there is a. Do I have a? Hold on. Let me just quit this out. Clear the screen. Let me go back to number 1. Save the document. Then I don't have to type all of this stuff. Just go into iterative mode again, and from here I can just do a while start date check for start date. Okay, it's still there. So while start date is lesser equal to end date, then go ahead and perform an update. So I'm gonna say full date, which is a dictionary. Gonna say update, and what do you want to update the values with? So I want to put in the key, and the key should just be the start date itself. So if it's 9th of March, then it should just be the 9th of March. So you're just gonna put start date. Or what about the value itself? Now the value itself is going to be taken from the aggregate value itself, because the aggregate value give me the value itself. So this is kind of where I want to subset it. So I'm going to just make sure that I do this correctly. Just going to copy that, make sure I didn't misspell it. And from here, I'm going to just say, now this is the aggregate dictionary. So I want you to take the value. If the value doesn't exist, then give a default value. So that is a good case for get. Okay. And within get, I want to just say start date. And if it doesn't exist, then the default is 0. So then it doesn't throw an error. Because if you don't do a get, if you just try to do something like, taking this value and then you try and subset it, then there will be values where it's going to be just none. If you do this, there are going to be values where it's none, and then you can't perform that add that we spoken about earlier. So what you want to do instead is to have it more robust and just say get. That's a better way of getting a value from a dictionary. And we're going to put start date. I'm going to put 0. So that's kind of a default. If it doesn't exist, give it a value of 0. If it does exist, take the value. And then what do we do once we've done this is that we move the start date by 1, because then it will, if you forget about the step of adding start date by 1, this loop will continue to run. It will never terminate because you're not altering the value of start date. So you want to actually do something here that increment the value of start date. And how you want to do that is you want to increment that by some sort of value. So for example, you want to add plus equals to 1 or whatever. In this case here, this is a date object. You can't actually add a plus 1. So here is when you introduce something that helps you add this by a number of 1. So before we go any further, let me just copy and paste. Now that I know that this is kind of how the logic looks like, let me just copy and paste what I have in the terminal and just do that. So var start date equals to is smaller than end date. Go ahead and do a full date dot update function. Within the update function, I want to pass in the dictionary. Within the dictionary, I want to have a start date in here, and I want to say aggregate date get start date 0. Okay, so this give me some sort of, at least it give me some sort of assurance that if anything fails, well, I still gonna have 0. If there is a none, if there is a invalid value, whatever, I'm still gonna get 0. Right, null, nil, anything. Right, then I want to at least increment that by 1. But this is a start date object. I can't really do this. So what is something I can use? Well, in Pandas you may have methods to do that, but here we're not gonna use Pandas. So what we're going to do instead is we're going to import another thing here. This is also from Python itself, from the core Python library module. So it's called import date from datetime, import time delta. So time delta gives you a way to say the difference between time. So you can say time delta, hours equals to 4, hours equals to 5, days equals to 1, week equals to 1, year equals to 1. So this is a good time to say something like time delta days equals to 1. So now I'm adding the start date by 1, and I'm continually doing this until I arrive at end date, because then this condition will be satisfied and it will no longer update. All right. So this is kind of what I'm doing, and at the end of it, let's just maybe do a quick print of full date. We save this. We're gonna quit out all of this now. Just quit out all of this now and just do a Python. We don't even need the interactive mode anymore, but we can see now from a quick eyeball, it looks kind of right. So 9, 0. And we take the value if it exists. If not, we fill it with a 0, and then we have 10, and then we fill it with a 0 of 8. So this kind of makes sure that there goes from 9, 10, 11, 12, 13. Make sure that there's no gaps between the dates. So even if somebody forgot to add an entry or take a holiday, or decided not to work on a weekend, it doesn't cause our script to behave weirdly. So we account for those days. If there is no days on that day, we just have a value of 0. All right. So, and we're adding this sequentially. We say increment that by 1 day at a time until you arrive at the end date. So that's kind of a way to guarantee a nice sequential timeline where there's no gaps in between. And then what we have now is actually kind of nice. If you want to stop here and just print out your table, you can already do that. But I also want, if you look at my T-score, I also have a cumulative. So my cumulative here actually sort of increment. This is 8, but when it comes to 11, it adds 8 plus 1, and it gives me 9. And then 49, 3 plus 9. This is a very big task, and this took me about 2 months to complete. It's a very large task. So because of that, I gave myself like 40 over score 2 months ago, and so it looks like I have I have a huge score in here, but it actually took me 2 months to work through it. So it's not actually a lot of score if you break it down by hourly spend and stuff. Anyway, that's 52 plus 4, 56 plus 4, 60 plus 7, 67, right? So this is kind of a cumulative. So I want to actually create some sort of a accumulator there, and I want to continually update that value. Because if I have that value, then I can create this column as well. So right now I don't have that. So let's go ahead and maybe do that. So I will say maybe an accumulator, and I'll set the accumulator value to be 0 because that's going to be the first value, 0. And then what I'm gonna do is, if you look at my foo date, this is kind of what it looks like. What I want to do is I want to iterate through this. There are a few ways to iterate through a dictionary. So there are a few ways to iterate through a dictionary. So one way you can do that, you can say for key and foo date dot keys, and you can perform your do your stuff in here. You can say do something in here, right? You can also iterate just through the values. And you can just iterate through the values. You can also just say for key values and then just iterate through both the key and the value. So if you say KV, and here you changed it to items, then it will just iterate through the key, and it will give you a tuple, and then the first item in the tuple will be a key, the second item will be a value, and you can just use them both at the same time. So for example, in this case here, if I show you what I have in my terminal here, this is the result of foo date, right? So I have the key, and then I have the value. I have the key, and then I have the value. I have the key, and I have the value, right? So what I want to do is that I want to step through each of them, and I want to accumulatively add the value. So what I'm going to do is I'm going to say accu plus equals the value. This is really straightforward, okay? And once I have the accumulator, I want to create this new column. So I want to maybe have something like you can call it like accumulated or rolling or what have you. So I'm just gonna maybe create another one here that says rolling date, and just have it here. So rolling date would look very similar to foo date. It would have the same keys. So rolling date would have to update with the same keys, and the key would just be the key here. So I want the rolling date itself to have this as the key as well. So we're gonna have key, but the value will be the accumulated value. So I'm gonna just have accu there, like this. Okay. So then it would give my rolling date would just show me what I see here, which is the date and the cumulative value, the date and the cumulative value. And I feel like at this point, I would already have these two. I just need to sort of combine them together in a way, just to put these two together into maybe a list of list format. And the way I can do a list of list format is to obviously first create a list. So I'm going to say combine list. And in the combined list itself, I want to step through, again, I want to step through all of the items. So I can say for KV. Actually, I probably don't need the KV because I can just take the key. I can just step through all of the key, and then I can just take the value from there. So I could just do a for k in foo date dot keys, and what I'm going to do is I'm going to say take this and append this into like a list of list format. So I'm going to say combine l dot append, and within the append, I want to append a list within that. So what do I want to append first? So obviously I want the first thing to be the date itself, so that I know what I'm actually looking at. So I'm going to have the k. Actually, let's be more explicit. Instead of k, let's just put key, right? Just to be more explicit, like that. And then I want to take the first, this column, this score column. The score column would actually be gonna be the foo date, because the foo date, this is the score column. This is not a cumulative column. This is a score column. So I want to take that. So let's do the foo date and say key. Then the third one, the third item that I want to have in each of these sublists is the cumulative itself, which I just created up here in the rolling date. So I'm just going to do the same thing here, like this, and this should give me what I need. Actually, let's just do a sanity check, make sure everything still works. Just combine L, and let's print that out. All right, so this is, we don't need the foo date anymore because we have that. But now let's see, we have a list. Within a list, we have a list of a list within a list. So this list itself, this is the key. This is the foo date key. This is the rolling date key. Then this is a second list. This is the first item, and then this is the foo date key. This is the accumulated key, right? And now you say, now it looks like it makes sense, because now again it goes from 10 to 11, but then you have the score to be 1. Here it does take the 1 and add the 8, so the accumulative is doing a good job. And then you move on to the next date, and now it adds 43, and what is 43 plus 9? That's 52. So it looks like it's doing quite a good job, right? I think there is also a technique you can do, something you can do. This is also built in Python. You don't actually have to do this, but it's built in Python anyway. So you can say from prettyprint, import prettyprint, and then you can go all the way down. And instead of this, you can say prettyprint. And if you run that, you see now this is prettyprinted. Prettyprint just kind of give you a more pretty format of printing it. So prettyprint will just show you exactly what you see in print, but it will show you all of this. So if you want to, this is again not against the rule. Why is it not against the rule? Because we're still not introducing anything that is external from what Python already provides to you out of the box anyway. These are all core Python modules anyway. Prettyprint included. This is all built into Python. It's called part of core module. So we're not really cheating, but we see that this gives you a lot of what you want now. I would say the issue is that I don't really want a datetime.date. This is kind of ugly for the end user. So what I want to do is I want to quickly change this into its string representation. And if I run it now, okay, this is much cleaner. I don't need to see the datetime.date, but it's now in a string representation. And in string representation, I feel like it's more concise and it gives you the same, convey the same meaning anyway. So this is kind of what I need now. So now I need to figure out a way to sort of print this out. And you can actually stop here and the project is done kind of. All you need now is to move on to the next chapter of like how do you take this and put them into your shell so that you can sort of have an alias or whatever other mechanism you get to wire up so you can just fire the script any way you want, right? I want to give it a header before I do anything. So let's go ahead and just go do a combine L headers. And the first one is going to be date, so let's call it date. The second one is going to be, whoops, accidentally quit that. Accidentally run that. All right, so clear the screen. The second one is just going to be score. And the third one is just going to be cumulative. All right, so you can, call it something else, but for me, it makes the most sense to just call it that way. And now we can just sort of print the table. I want to actually talk about something here, is that at this point, we completed our project. We actually have what we want, and we set out to use no Python package, and we've done all of this. So if you want to, the next 10 minutes is kind of optional. You can just go in there and just jump forward to 10 minutes later and just look at how I would take this and put them onto my WinRC file or G shell, whatever, and just to have a quick shortcut to access this Python function, execute that. But for those of you who want to actually look at something else, I want to also talk about something that allows the end user to have something like an optional quality of life improvement. Is that I want to introduce a concept of like an optional importing. I want to say that if the end user already have tabulate installed on the main environment, then you can use tabulate to print that out. So in this case here, I'm actually introducing a third-party library. So if you do want to do this, you can. But I show you that in a way I try to not break the rules by making sure that I have a fallback. If the person doesn't have tabulate installed, it will not fail. It will just print a slightly less pretty looking table, but it will still work. All right. So I feel like I still play fair. I don't feel like I cheated. But let me show you what I mean by that. Right. So I'm gonna just do a quick try. I'm gonna say try this. Try from tabulate import tabulate. Now, if the end user actually have tabulate, if your customer or you already have tabulate installed, then it's not gonna complain. It's just gonna do what it needs to do. But if it doesn't, then you can just do an import error, because if it doesn't, then it would give you an error and you just have to say pass. And the reason you do that is because if you wanna actually now print using tabulate, you can now. So let me just keep the pretty print there. But I want to say something like this. I want to say that if tabulate is within the modules that is loaded, then I can use tabulate. And tabulate takes a few things. The first one is the combine list. So pass that in as the first one, and then it takes the headers, and the headers would just be the one that we just created, would be in here. So let's just do that. And then finally, it would take a table format, and you can choose a different kind of table format, whatever table format you want. I'm gonna call it I'm gonna use the table format called pretty. Okay, and now it's complaining that, hey, there is no sys module. I don't know what sys is. So what do you need to do? You go all the way back up and you do a import sys at the top, just like this. Okay. Something about putting up all the dependencies up here is that you can just right click and just say sort your imports, and it will sort. For me, I always follow the best practice anyway, so it doesn't complain. But if you general rule, if you want to follow like PAP 8 and stuff, is that you want to input all the imports that are completely built into Python without third party. You want to put them up top first, and then you put in any libraries that needs to be installed, third party libraries like this one, and then you put in your own modules. So if you're importing from any other shell, you want to do that as well. So in this case here, if I just go to my terminal again and I just say python demo.py, there I have it. That's exactly the table that I want. So that's perfect. Give me everything I need. And if it's in there, you print that out. If not, you can just print out the combine L, right? For example, you can just do this. Print combine L. So if it doesn't have that, you still doesn't complain. You just have to do what's the next best thing. And that's kind of it. That's a very reasonable task. So if the person doesn't have the tabular installed, it's still not going to complain. It's just going to end up just printing using the normal print function. So here we're not cheating, we're still playing within the rules because anyone can use the function. If you make this into a Python package, anyone can install the package without installing any dependencies. How pretty is that? How good is that? You're saving somebody 500 MB, 500 megabytes of sizes just from not using numpy or pandas or anything like that, just running your own function. So that's pretty neat, right? But I want to show you though that if you want to make sure that your table still looks somewhat good looking, like this is not really the best looking table at all. So what I did was I go ahead and create my own tabulate function. And this own tabulate function, I don't want to spend like way too much time to talk about it, but I can maybe quickly show you that I have it in here in create table. So I have this maybe 12 lines of code that does that already, and these 12 lines of code, they're not very complicated code. If you want to take a look, you can just pause the video, or you can just go to my GitHub and sort of take a look at it. But they're completely optional. If you want to, you can do that. If you don't want to, feel free to just ignore that. But I'm just gonna import that. So I'm gonna say from my utils library. So I put them into utils, and within utils itself, I have the create table. So that's the name of my file, create table, and then I import the name of the function. What do I have it? Create table. The name of the function I gave it is called create table. So I'm going to say create table like this. So I'm going to say try this. If not, then import my own custom create table. All right. So the create table then now that it's been imported, I can use this. So instead of doing the pretty print, I can just go ahead and say create table, and it takes a few things as well, but it takes exactly the same argument as tabulate. Just to make it very consistent, I can just copy exactly what I have here. Okay. Now to show you how it looks like. If I deactivate my environment, so I have a clean Python installation, I have no tabulate, what would it do? So let me just show you. If I say tscore, this is how it's gonna look like. It doesn't look that bad compared to if you have pretty print, it looks prettier, it looks fancier, but if you don't have it, it doesn't look that bad. Okay, so that's kind of my own function of creating a table, and that's kind of how you create a whole script. And let me just pause here to show you what other parameters you can pass in here. What other choices do you have for table format? Okay, so I'm in the GitHub library of Python tabulate. So to install that, you have pip install tabulate, and then what you do is that you go all the way at the bottom, and you see these are all the supported table formats. So you can pick one of this. You can pick plain, simple, GitHub, grid, fancy, grid, pipe, so on and so forth. So for example, I can just very quickly go into go into my terminal again, and I can just adjust one of this, and let's say something like python demo.py, and you see that now if I look at the plain, it looks just like the plain table that I have. And if I change that to GitHub and I run that, you see that now it looks like the one you would expect from the GitHub markdown format. And if you change that to grid and you save it, and now it looks like a grid format, and now you have the grid. You can also have something called a fancy grid like this, and you run that. Now it looks like this. It has a fancy grid with somewhat of a kind of like a double border right out there. So for now we don't really need the pretty print, just have to remove that. So really give you a lot of options there. but it's up to you if you want to pick one of this. You know, if you don't care for too much of this, just stick to one of them. You can read up off documentation. I'll put a link there, but it's basically Python tabulate. Search for that, and you'll see all the different options you can pick for your table. And what is also really cool is then you give a fallback option so that you make this completely optional. If the person doesn't have one, it's not going to complain, right? And this will avoid the kind of error that you see. For example, if I don't do this, if I just do a simple from tabulate, import tabulate, if I just do this, and if I deactivate my environment, and I try to do something like python demo.py, you see that there is a module not found error, no module name tabulate. So I'm actually avoiding that error because what do we say the rule of the game is? The rule of the game is no third-party dependencies. So if we make this into a Python package, no one should have to install any other package before they can use this. So if they don't have that, we want to provide some sort of fallback option. One thing you can do as well is you can do something like a try block here, and then you can also try to do something like you can create a warning and say, or not a warning, but a simple friendly message. You can do a warning. You can just go and import warning and do something like warning something. But here I can just say something like tabulate is not loaded, or tabulate not loaded using plain tables. So just kind of give a nice message, and then at the bottom of it, you will see that, hey, tabulate not loaded using plain tables. So you're telling the end user that, hey, if you want to have something fancier, you want to look at pretty tables and stuff, then go ahead and load tabulate, and you can maybe provide that in the documentation. For now, I probably don't even need this. Just want to get out of the way, just want to do his job and get out of the way. I don't want to be intrusive. Just if it's there, use it. If it's not in there, just fall back to another thing, right? And then what we can do now is to put all of this now into a nice function on its own. So just gonna tap all of this in and just say define main, sort of this, and then at the end of it, we can just have our if name equals main, and just execute the main function because we call it the main function up there, right? So yep, we name it the main function, runs everything there. Now we just have to search for all the print statement and remove all of them. If there is any kind of print statement, we just want to remove. This is fine. Okay, we don't need the pretty print anymore, so we just remove that. That's Ctrl+Shift+K to remove that. And now we keep it nice and tight and without any kind of fluff. And that's about it. So now it's time for you to then spin up your terminal and try and test out everything, see that if that works. So now that I'm in my terminal, I just have to create some space up here. All right, and within this space, if I just if I'm not in any environment and I can just do a tscore, I should see this. But if I'm in an environment, then I can create tscore and I get this nice printed table. So how do I link that to this? So there are a few steps you need to perform. The first thing is you need to make this executable. So you do a chmod and you have to, let's see if this is in there. So that's demo.py. If you name it something else, you want to call it something else as well. So you want to say chmod. That's basically saying that modify the user privilege, and you want to give it execute privilege. So I want to say +x is kind of add execute privilege, and then the name of the file. So something like this. In this case, it will be demo.py. All right. So if you call it demo.py, if you call it something else, you want to just put that. And then once you've done that, you want to go to your if you're using a G shell or the bash shell, you want to just add an alias. So you do an alias to make sure that the alias points to this. So let me just go in and say G shell, and within G shell, I have my alias. So this is my alias. So this is my alias. And here, what I'm doing is I'm pointing to this location. I'm saying that every time I say tscore, I want you to go ahead, run this script. Okay, so now I'm going to quit this out, and that would do. Just add the 2 steps. Oh, make sure that at the top of the script, if you want to have all of this go through, you want to at the very top of the script, you want to add a shebang. So a shebang starts from this pound sign. This is called a shebang. A shebang is saying that, okay, what file do I use to execute this? Now, because I'm in a virtual environment, if not, you can just say Python 3. But because I want to make sure that this is also in an environment, so I can say bin env Python 3. Okay. If you don't know what this does, just copy that, paste it down at the bottom in the terminal, and you see that it goes into Python. So it's using Python to execute all of that. So that's kind of what it's doing. So that's it. Now you can save it, and I guess you can actually just have this also move all the way down into a main function, like a doc string, and I think that's pretty much it. That's all. That's all. You know, that's once you've done 2 steps, you add this, go into your create the chmod, add the user, add execution rights to this file, privilege to this file, and then once you've done that, go into your shell and make sure you have set up the alias. And once you've done that, congratulations, you just have a nice simple analytics tool in your terminal without using Pandas, without using any third-party libraries. So that's part 1 for this series. And if you enjoy this kind of content, you can let me know. I will probably do more of this, using, just going through, you know, creating this kind of like analytics systems, or doing data science work without actually using any third-party package and stuff. And we can do something more challenging maybe next time. So this is kind of what I have. I'll see you probably in the next time.